Just open up the data that we need to use. Okay, just let me know when you're ready.
One sec. I'm opening the data files.
You're good.
Don't know why it's taking so long.
Mine's been disconnecting a lot today.
Yeah.
Yeah.
Hmm.
But luckily when I reconnect, everything's still there, so it's not like lost.
Oh, that is good. Maybe it's because of all the people here for devotional again.
Maybe. I can't believe that. It's 2 weeks in a row.
I know. It's weird. He came to dedicate the new science building, I think.
Oh, okay.
Okay, now I'm ready.
Okay. So I'm just doing the computing variable and whatnot just to get it ready to answer the questions. Okay. Okay. Suppose we have a set of paired data and let D equals X after minus X before. The null hypothesis is the mean equals 0 and the negative is not equal 0. Standard deviation is not known. Jordan collects a sample size of 9 people and computes that D equals 2.2 and the standard deviation is 3.3. What is the value of the test statistic?
Wouldn't it be 2.2?
Is that the t-score?
Oh, maybe it is.
I think it is, but I'm not sure. Are we supposed to use... Okay, we're not supposed to use that data.
Yeah, it doesn't have anything for the data file, so...
So we just have to do it by hand, I guess.
Yeah.
T-score? Ugh. I'm gonna have to open up my prep. I can't remember those equations off top.
Me neither.
I think it was in, yeah, the equation 11, I think, or 10 from last week. Yeah. So t equals x bar minus the mean over standard deviation divided by the square root of.
Okay. I remember that now.
So
So we're doing the same thing we've always done. We're just using the information they gave us and they call it something slightly different. So T is going to be the D with the bar over it, so 2.2.
and then just minus 0, right?
Yeah.
Minus 0, and then divided it by
3.3 times the square root of 9.
so 0.222222.
That one's fun.
So it says to round to 3 decimals, so 0.2222. Okay.
The probability of obtaining a test statistic greater than Jordan's test statistic is 0.0403. Use this probability to determine the p-value for Jordan's hypothesis test.
So we'll just go to the little app. So 0.0403. And it's going to be the two-tailed, so we just want to make sure we get both sides. And then it'll be, the degrees of freedom is going to be 8, so it's the same size as 9. You get 0.9688.
One sec.
Okay.
Everything's all messed up. That's took me a long time to find the applet.
Oh, you're good.
So putting the probability that they gave us in, which is 0.0403, right?
Yeah.
And then we see what the
And
z score is. As
The
the
degree
two-tailed,
of freedom is going to be 8.
8.
Are you on that other app?
The probability applet?
It's the one with like the green, red, and white flag
No,
looking
I
thing.
forgot about that one. So that's where you got the degrees of freedom.
Yeah.
Okay, it's like,
I don't understand why she has us just. I wonder if it's the same thing. I'm gonna see. 0.0403. It is the same thing,
huh.
I guess. But in the other applet, I got 0.9688, so I would have rounded it to 0.969. Should we just do 0.968 since it only gives us the normal probability app? It's not giving us the other one.
Yeah, you should probably use that one.
Okay. 0.968.
And how did you get that anyway?
So if you just do it in the normal probability app, just put in the z-score,
Mm-hmm.
0.0403, and then make sure you have both tails highlighted since it's a two-tailed.
Okay, so we don't put it in the area. We're wanting to get the area.
Right.
Oh, okay, that's what I did wrong.
Mm-hmm.
I'm so glad you're here. All right.
Okay, so now we're going to start using the data.
Yay. The data file, chapter 12.
Not sure if I did that.
Which one is that? Let's see. Ah, found it. Okay. So what do they want us to do with it? Perform a paired sample t-test. Be sure that the test does group 1 minus group 2. Okay, let's just get that far.
Data A. It's group 1 minus group 2?
Yes.
Okay.
Okay, and then How's it going?
Good. Okay, so the question is asking us, what is the t-statistic? So we'll go to we'll calculate the sample, I forget what it's called.
T-test?
Yeah,
Okay.
the one sample statistic, or the one sample test box.
Okay.
And mine says, 0.407.
Let's see. What are we using for the mean?
I just put 0.
Okay.
Because I remember from last week's quiz, when I put the mean in there, it would just say 0.000.
Oh, really?
And I remember
Yeah.
talking to Sister Withers, and she said, just make sure you put the test value as 0.
Huh, that's interesting. It's like the opposite of what the textbook tells us.
I know.
Okay. So you got 0.407?
Yeah.
That's what I got too. All right.
Okay. And then what's the p-value?
And to find the p-value, we just put it into the normal probability applet, right? As the z-score.
Yeah, I'm going to do it on the other probability applet too,
Okay.
just because we were given the degrees of freedom. So let's see what we get on each app.
Okay.
Did you get 0.6886?
I got 0.6840. And it's a two-tailed test, right?
Huh?
Is it a two-tailed test? Just gotta check that.
Yes.
Okay. Yeah, I got 0.684.
Okay, let's just do that. I don't know why, because in the textbook lesson, it teaches us to use that other app, you know?
I know.
And then in these quizzes, it's
The other one.
this applet. Oh well, we'll just use that applet. So it'd be 0.684?
Yes, I think. Let me look again. Yep.
Yes?
Yes.
Okay. What is the correct decision based on this evidence? So the level of significance is 0.1. So it's bigger.
Which means we don't reject the null.
Right?
Fix it out for a second.
I'm gonna double check real quick.
Should fail to reject the null because if it's bigger.
Yeah, fail to reject.
Okay. Awesome. Question 8. Suppose your alternative hypothesis is instead that the mean difference is greater than 0. What is the correct position based on this evidence? So the normal probability applet, I just unshade one region,
Uh-huh.
the left one, and it leaves me with 0.342.
So it's still bigger.
Mm-hmm.
So that means that we have insufficient evidence, right? If we're failing to reject the null.
Yeah.
Okay, so between those two options, the mean of the difference is greater than 0, that the mean of the difference is equal to 0.
We have insufficient evidence that the differences are greater than 0.
Is that what we want to do?
I think so, because that is what the alternative hypothesis was, and we're not accepting it.
Yeah, that makes sense. Okay, now we're going to the next data set. B. Does it say what we're subtracting from what?
Group 1 minus group 2 again.
Okay.
Okay. How's it going?
Good. I just had to redo those because I was doing group 2 minus group 1.
Okay. But-
Okay, so what is
Or
greater
the
than
degrees.
BF? It's gonna be N.
Yeah,
because
because
BF
degrees
is
of
always gonna be
freedom.
minus 1.
Yeah, right.
Okay.
Okay. What is the p-value? So we have to find the t-value, right? And then we can find the p-value.
Yeah.
Okay.
So the t-score should be 3.737. That is tiny. And it's two-tailed. Did you get a tiny number?
How'd you do it?
So I just put the 3.737 in the probability app,
Mm-hmm.
and then the area reads 1.8623 e to the negative 4.
Well, sounds right. Let me just hurry and finish. I just can't remember, is it a two-tailed or one-tailed test?
Then we have to round to 3 decimal places.
Mm-hmm. Hannah, do you remember if it's two-tailed or one-tailed?
It's 2.
Okay.
Yeah.
Yeah, I got the teeny number too.
Okay. So we'll definitely reject the null hypothesis because it's definitely going to be less than 0.01.
Mm-hmm.
But how should we round that to 3 decimal places? 0.000? Because I remember in the textbook it said to like,
I don't know, because it's scientific notation. I don't remember them saying what to do.
Do you remember when they were talking about this? So where we find the t-score in that one sample test box, and they said to find the p-value using that test box, you can use the sig two-tailed section.
That would be, let me see. I'm thinking it was less than 11.
And it said like, if it's a one-sided test, then you just divide that sig number to 2.
Yeah, I remember that.
But if it's two-sided, you just use the 0.001 or whatever number it reads in that box.
Mm-hmm.
Do you want to try and just put 0.001?
Sure, let's do that.
Okay, let's see. Because I don't know what we would do with that number.
Yeah, me neither.
I mean, technically it could round up to that if we really wanted it to.
I guess that's true. So we reject. No.
Yes.
Okay. You decide to try another alternative hypothesis. This time, you use the alternative hypothesis of greater than 0, and you keep the same level of significance. Did the p-value increase or decrease?
Well, we do 0.001 divided by 2. It decreased.
Mm-hmm. I agree.
Yeah.
Huh?
Sorry, I think the connection is just a little bad.
Yeah, I'm sorry about that.
No, you're fine. So, do you agree that the p-value would decrease?
Yes.
Okay.
And then our test, like our value is 0.01. So our p-value is going to be smaller than that, right? So we'll still reject the null?
That's what I think.
Okay. Man, these quizzes just keep getting longer and longer.
I know. Worst comes to worst, if we get those 2 answered ones wrong, I mean, we obviously will know what the answer really will be.
That's true.
And we'll be able to understand, too, why.
Mm-hmm. Okay. Based on your response from the previous question, what conclusion do you make? So it should be we have sufficient evidence
And that there is a mean difference between the 2 groups, right?
Yeah.
So C.
Yes.
As we have seen, the p-value depends on the alternative hypothesis. In general, which alternative hypothesis will give the smallest p-value? Well, either B or D, I thought, because it's one-tailed.
Yeah, that's what I was thinking.
Should we do not enough?
But
Or would it be B because it's pointing to the left, and the left tail is always negative?
I wanted to think.
B?
Yeah.
Okay. That makes sense.
Okay. Determine the 95% confidence interval for the mean difference between the 2 groups using group 1 minus group 2. Isn't that what we already did?
So we're going to find that. So yeah, so all we have to do is go to the analyze and then explore box.
Okay.
And it'll be upper and lower.
The most useful found this textbook.
You said you go to analyze and then explore?
Yeah, you'll go to the explore box, and then you'll put the difference variable over and press OK.
I'm just not finding the explore box.
Oh, go to analyze and then the descriptive.
Oh, right. Okay. The difference, move it over to the dependent list.
Why?
Yeah, move the difference variable over to the
Who's?
right box up top.
Okay. Gotcha.
Sorry, my connection was lost to the thing, so I have to reconnect.
It's okay. It's hard.
Yes. I guess this is kind of like the downside to that VMware.
Yeah,
Sometimes it's super slow.
it's true.
Okay. Yeah, so for the 95, okay. Well, the point estimate, shoot.
Do they mean the mean for the point estimate?
Because then what would the margin of error technically be?
Margin of error? Well, let's see. We learned how to do that, which it makes it would be our mean, take away our t-score, multiplied by the standard deviation, divided by the square root of the number, and then we do the same thing, but we add, wouldn't it?
Right.
So when you did the explore thing, you came up with the box with the descriptives. Does it give you the same mean as it's giving me of 11.9545?
Is this the data B?
Yeah.
11.9545?
Yes, I got the same thing.
Yeah.
So we're going to use that, right?
Right.
And then we're going to subtract our t value. I wish I remembered what that was. Let's see.
It should be 3.737.
Okay, thank you.
Okay, so we minus the t-score from the mean.
Mm-hmm.
That equals 8.2175. And then what?
And then we want to multiply it by our standard deviation, which would be...
Multiply it or divide it?
Well, we're multiplying it by the standard deviation divided by the square root of our sample size.
Oh, okay. So standard deviation 8.21.
Are we looking at standard deviation?
15.003.
Yeah, okay.
Yeah.
Divide that square root of the number. Let's see, how many values do we have? We have 22. Okay.
Should get 26.285.
One sec, I'm almost done. Okay, what was that number again?
26.285.
No, I didn't get the same number.
Shoot.
Let's see. I'm gonna try this again.
So 11.9545 minus the t-score, which is 3.7. I forgot.
737.
37. This thing keeps. Come on.
Are we trying to find the margin of error?
Is that what we're doing?
That's what I'm asking, yeah. Oh, I gave you the wrong formula.
Oh,
That's why it's not working out. Okay, so what we actually want to do, 0.96, because that would be our 95% confidence interval. And we want to multiply that by our standard deviation divided by our the square root of our number.
One more time. It kind of like cut out.
Yes. Okay, so we're taking 1.96 and we're multiplying it by the fraction of our standard deviation over the square root of our sample size.
And where did you get 1.96?
1.96 is what we're multiplying them by.
Why though?
Remember when it gave us the margin of error is 2 times the standard deviation divided by the square root of n, but then it told us that wasn't quite accurate, and they said for a 95% confidence interval, it's actually 1.96. So I'm just taking it from the lesson before.
So 1.96 and then what?
Then we're going to multiply it by our standard deviation
15.00310.
over the square root of 22.
$6.269.
Huh?
Did you get 6.269?
I haven't done it yet, actually.
Oh,
just telling you. Let's see. Our standard deviation was the 15.003.
Yeah.
Okay. 1 sec. Okay, what was that number again? The 6.269?
Yeah.
Awesome, that's what I got too. Okay.
Okay, so then the lower bound and upper bound will be in that box. And
Okay.
it's really good. Connection. There we go.
What did we put for our point estimate for the 9? Oh, that was our mean, right?
I just put the mean, so 11.955.
Okay, I was like, somehow I skipped that question, but I know we did it. Okay, input the lower bound.
So that's 5.303. And the upper bound is 18.607.
Okay, where did you get those numbers again?
So you'll go to your little output box,
Right.
and it's right below the mean in the descriptor.
Okay, I see it now. I was like, I know it's in this box somewhere, but I can't find it.
Yeah. No worries.
Okay. Thank you.
Yeah, you're welcome. Okay.
That's all of them, right?
Yes, I believe so. And if we wanted to double check those upper and lower bounds, we'd take the point estimate minus 5.303, and that's going to equal like our margin of error, roughly.
And it does. Awesome.
Yeah, and then if you add 11.9, or wait, what was it, 955?
Yeah.
And then if you add the 18, or no, you take 18.607 and minus 11, just to see the difference and see if you have the same marginal error. Same thing.
Yeah, the 6.652.
Yeah, I mean ours is a little off, but
it's pretty close.
yeah.
Awesome.
Now if we get those wrong, I'm gonna be PO. I think we did all these right.
Good.
I sure hope so, at least.
I think
Okay,
so,
ready?
too. Oh, yeah.
You should drive down Matt Benson and then come pick me up. And then let's just park over.
75%. What?
We got
What?
3 and 4 wrong.
We got
And
17
6.
and 15.
So we're getting the p-values and the t-stats wrong.
Let's see. Maybe if we go to our lesson. Let's see how to do that.
So the t-stat. Oh. Okay. For number 3, I just did the calculation again. I don't know if we just. So we take. Oh, never mind. 3.3 times the square root of 9, which equals 9.9. And then 2.2 divided by 9.9.
Where are you getting all your numbers?
For number 3,
Yes.
problem above.
Oh, okay.
Where it
So
gives
you
us-
said you did 3.3 times the square root of 9?
Yeah, is that what we're supposed to do? Or we're supposed to do 3.3 divided by the square root of 9, aren't we?
Yeah, for the.
The t-score.
Ooh, let me see. T-score. Yeah.
That's what we did
divide it.
wrong. So it's 3.3 divided by the square root of 9 equals 1.1. And then we'll do 2.2 divided by 1.1.
Okay, that makes sense. Which would be 2, right?
Right. So that's a
Okay.
little different.
Mm-hmm.
And then 4, probability of is greater than, oh. So for number 4, I think it changes from a one-tailed or from a two-tailed,
To a one-tailed.
as it's saying the probability of obtaining a test score greater than Jordan's test statistic is. When we find that in the probability app,
Mm-hmm.
we need to
We
divide
need to.
one side. So instead of 0.968, it's going to be 0.484.
Okay. It's good that it makes sense what we did wrong. I hate it when it doesn't.
No,
Okay.
for sure.
And then for 6, what is the p-value? The test, let's see. It's 210, so we got that right.
Let's see, what was 5? 5 is 0.407. Okay. And then 6, we need to find the p-value. I think it's the same answer that we had except negative.
Why negative?
Because if you think about it, oh no, just kidding. So on the homework quiz last week,
Uh-huh.
p-value right, but the t-score wrong.
Really
And I was
strange.
like, Sister Withers, how is this possible? And it was just because I didn't have a negative sign.
So you're thinking it might be the same thing for the p-value?
Right. But it isn't the same thing because we do have the t statistic. We just have to find the p-value now. The guy was doing it.
Right.
So
We use the normal probability applet to do that?
we should.
Okay.
So
And it's
0.
two-tailed. So
0.684.
yeah, it's the same answer. Huh.
Should we try using the other probability app and then putting the degrees of freedom in and whatnot?
I guess, might as well, just to see if it makes a difference.
Okay, so it's gonna be 0.689.
Okay. It's weird that it gives us a different value. They should be the same.
I know.
But I guess we can try that next time.
Okay, 7. All these right, so that's good. Fail.
Yeah, I think we don't get one wrong. Yeah, till 15. So, we won't get this one.
B. Point. Oh, I'm glad we got 10 right.
Yeah,
1.
me too.
You know, we could go on that data file what the p-value is in the out talking about.
I think so. Is this still for B1?
A1.
A1. Okay. I don't know where that one went. I guess I'll just do it again.
Yeah, me too.
So we're gonna do the explorer thing, or are we making the one-tailed? Oh yeah, the one-tailed.
Do the one sample test box, yeah.
Right.
Oh.
Bless you.
My thing's frozen again, so
Yeah, mine didn't do it for some reason, so I'm doing it again. Okay, so for my p-value, if it's two-tailed, it would be 0.689.
That's what we have.
Huh.
Okay. Okay, that's good to know. Disconnected. Awesome. So then, yeah, let's go back to 15 and we'll use the. Or I don't think 15 has anything to do with the p-value. I'm not sure. I can't remember.
The thing is, checking that when we have our z-score of 0.407, I'm checking what it is. And the probabilities,
I couldn't hear you.
sorry. So I was just checking on the probability applet to see what changes depending on if it's a two-tailed or a one-tailed.
Mm-hmm.
Two-tailed is larger, but the one-tailed to the right, the greater than, is the same as the less than. So maybe it's not enough information. Depends on the problem because it's not really changing, and we can't select both less than and greater than.
Right. I could agree with you on that one.
Okay.
Sorry, I'm just making my way up to that problem.
No, you're good. I'm just writing them down on a piece of paper, and then I'm gonna put them in. It's easier for me. So you're a speed demon sometimes.
Sorry.
No, it's good. It's good.
Feel free to, don't ever hesitate to tell me to slow down. I will not get offended.
Okay, good.
Ugh, froze again.
That's a bummer.
I'm too quick for the computer.
That's funny.
Oh, jeez. Okay, so not enough information. Okay, so 16 we got correct. 11.9.
Mm-hmm.
And then it was 17 that we didn't get right.
Right. So we just need
So
to
should we
know.
try doing, since we got the lower and upper bound, should we try finding the difference like we did
Sure.
between those the two numbers and the mean, and then just put that because it's close?
Maybe. Or should we just try and do the calculation again and see if we did something wrong?
Yeah, we can do that too.
Okay, I'm just trying to remember which data file it is. I'm going up to C. Okay, it's the B1. So we just need to find out what our standard deviation is and what our sample size is.
Okay, so our standard deviation is the 15.00310.
Mm-hmm.
And then we divide it by square root of our sample size, correct?
Right.
Okay, I got 3.1986.
One sec. So let's see, 15.003 divided by the square root 22, and then multiply that by 1.96. What did you get?
The standard deviation divided by the square root.
Right.
198.
Okay, that's what I got too. The thing is, we need to know, we have to multiply that by 1.96 because it's 95% confidence interval, correct? And that'll give us the margin of error. Thing is, then it gives us the same number as we have written down, and it's not correct.
I think since we have both the point estimate, froze again. Since we have the point estimate correct and the upper and lower bounds correct,
Mm-hmm.
I think if we find the differences between each of those numbers, since it comes out to be the same number, that's 6.52 something. I
Yeah.
think that might be the same thing.
Okay. We can sure
But
try.
I'm not positive. I'm gonna go to that margin of error. What lesson is that margin of error equation from?
It is in lesson 10.
So it's the z-score, right? Which would be the 1.96.
Right.
1 second. $6.269. Yeah, same thing. Oh, this is the most it's disconnected in one day.
Oh no.
Because the lower and upper bound is basically saying these numbers you're going to find relatively your mean. Margin of error is like how many numbers is spread between those two.
Right.
That's just what I'm thinking. 0.9.
So you're thinking of doing 18.6065 and subtracting the lower bound from it and seeing what it is?
Yeah, so minus 5 point. So I'm going to take, before I round, 11.9545 minus
Okay.
5.303.
Am I echoing right now?
And that gives us 6.6515.
Okay.
And then if you take this, so you'll take the upper bound now, 18.607 minus 11.9545. You get almost the same thing.
Oh yeah, you're right.
So I think we should put in 6.2.
Okay. I think that's wise. That is a great deduction. Just saying how to do this in a different way.
Okay. Yeah, I'm going to submit it. I answered everything. You got a 95%.
Woo woo! That's awesome. Ooh,
Okay, which
that's
question 4 again. What the heck?
4. But we didn't get question 4 wrong, did we? Oh, we did. We did.
It's the whole p
Huh.
value thing.
I hate p-values. Just saying, for the record.
Yes, me too. How did you do on that exam?
Honestly, I have no idea. Oh, yeah, I think I got a B minus or something like that.
Yeah, I think I did too.
Yeah. Sister Withers, though, she recorded my exam, her going over my exam, because we couldn't meet because she had to go somewhere. I haven't looked at it yet, but that was super nice of her. So hopefully I'll know what I did wrong.
Oh, that's nice.
Yeah,
That's
I
good.
thought so too.
Cool. Okay, well, right on.
Well, thank you, Hannah.
Don't mention it. Okay, I will see you on Thursday.
All right, sounds good. I'll try not to forget our meeting this time.
You're good. Have a happy Valentine's Day.
You too. Bye.